that sound quality, picture quality, everything is fine? Yes, please. Yes, that is, you are on BYJU'S Exam Prep, the most comprehensive app for all exams, right? First of all, let me know that sound quality, picture quality, everything is fine. And now we are going to discuss very important topic from network, that is first order transient. Each and everything about the first order transient, and we will discuss first order RC circuit, right? So inform me that sound quality, picture quality, everything is fine? Yes, please. Now join the session. This session is very important because we have to get the command over what RC circuit, resistor capacitor circuit, and what is the nature of the capacitor. And because this topic is what very important topic, and that's why once we will get the command over this topic, it will become very easy for you to solve the question from what analog. Okay then, very good afternoon Navneet. Now this is a complete first order RC circuit concept with question practice, and this is my introduction. Myself Sanjay Rathi, 21+ years of teaching experience, and these are my ranks. AIR 16 in ESE 2005 and AIR, this is the 21 in ESE 2008. Now this is a session for you. We are going to start concept capsule course, learn gate fundamentals and tricks with the experts. For mechanical and civil, that is the Tuesday and Saturday, that day is fixed. And then for electrical and electronics, Sunday and Wednesday, that is the date is fixed. And for computer science, Sunday and Thursday. Here we will provide you the important concepts within 15 minutes. Okay, we will try to cover the concept, important, very important concept, right? So, and what is the timing? The time is what? 9 AM, right? So 9 AM, that is the time for this concepts capsule, learn gate fundamental and tricks with the experts. Now what is the today's agenda? Here we will get the idea about transient, why we are getting the transient in any circuit, why we are getting the transient. We will discuss. Here I am going to discuss the nature of capacitor and inductor. That is what is the capacitor, what is the working of the capacitor, and what is the working of the inductor, and why we are getting the transient. What is the switching, what is the sudden change, for sudden change or abrupt change or discontinuity in the input, what will be the response of the circuit. And that is the answer why we are getting the transient. Okay, Navneet, it is not available on my Telegram channel because I have given them. Okay, I will ask them to upload the PDF of the previous marathon class. So definitely I will ask them. Okay, now sudden change, why we are getting the transient. Second thing, I will give you the formula. Formula means very standard formula to solve the first order question. First order RC circuit, first order RL circuit, right? Very simple formula for first order circuit, right? And in this session I will give the idea how to find the initial value from the first order circuit, and how to find the final value, and how to find the time constant of the circuit. Time constant of the circuit, right? Because we have idea to find the time constant. To find the time constant, simply in RC circuit you have to find what? RTH into C, or in case of RL circuit you have to find the L by RTH or L by R equivalent, or L by R equivalent. So we will get the idea how to find the time constant. Means we have to find the Thevenin's resistance. The circuit may contain what? Independent sources or what? Dependent sources. Then these three things are very important. Initial value means exactly at t equal to 0 what will be the value. Final value exactly at t equal to infinite, what is the value. And what about the time constant of the circuit? If we have idea how to find these three values, then we can use this formula. right? We can use this formula, and then the question from first order transient circuit will become very, very easy for you, right? Now remember that we are getting the conceptual questions from first order transient only, right? And on from second order we are getting question like what? Just formula based question, and that's why you have to get the command over this topic. Okay, C and L, capacitor and inductor, and finally we will discuss what is the steady state. So that is the agenda of today's session, right? If you want anything, then you can give me the comments in comments box, and I'm going to give you some assignments, and we will discuss the questions from the assignments on next session, and I will upload your solution also. Okay then, so ready guys? Right, now transient response. Why we are getting the transient response in any circuit? Why we are getting the transient response, right? तो नेचर ऑफ द कैपेसिटर एंड इंडक्टर. तो एक बार जरा आप इस सेशन को लाइक कर लीजिएगा, अपने ग्रुप में शेयर जरूर कर लीजिए, और चैनल को अगर आपने सब्सक्राइब नहीं किया तो प्लीज सब्सक्राइब द चैनल, बिकॉज वी आर गोइंग टू टेक वेरी वेरी इंपॉर्टेंट सेशन ऑन दिस चैनल, राइट? तो प्लीज सब्सक्राइब आवर चैनल. ओके देन, now why we are getting the transient? First of all, in any circuit, if we are having the inductor and capacitor, then definitely there will be a transient. Why? Simply because inductor does not allow sudden change of current, right? And capacitor does not allow sudden change of voltage. What is the meaning of this? IL0 negative is equal to IL0 positive. Means before switching and after switching, the current through the inductor will remain same. It will take time to change the current through the inductor, okay? And that is the problem. So when we are giving the switching, for example, watch this circuit. Watch this circuit. Let this is the 10 volt battery, and there is a switch, and I am connecting a circuit. Then exactly at t equal to 0 we are closing the switch. When we are closing the switch, what is the voltage at this point? The voltage at this point is 0. So exactly at t equal to 0 negative, just before switching, at this point, like this is the Vi is equal to 0, and exactly at t equal to 0 plus, after closing the switch, Vi will become 10 volt. So this type of change is called what? Sudden change, because of switching action. Similarly, when we are giving the step signal, this is the step signal, this is the 10 volt. So when I am representing the input 10 ut, similarly it is 0 for t less than 0, it is 10 volt for t greater than 0. So exactly at 0 what will happen? Exactly at 0 there will be the sudden change. There is a sudden change at this point, and because of this we are getting the transient. That is the reason. Now when we are giving this type of input, we are closing the switch or we are giving the step signal, there is a sudden change in the input. What about the capacitor? This capacitor does not allow sudden change of voltage. So before switching and after switching, the voltage across the capacitor will remain same, and before switching and after switching, current through the inductor will remain same, right? And that is the reason why we are getting the transient, right? Sometimes what will happen, we are simply removing one resistor. For example, Again there is another case. If suppose that is the connection, let this is the V volt, 10 volt battery. We are having the number of components here. Right, let this is the diagram. Okay, that is the diagram. It is under steady state. Okay, suddenly we are removing this I4. Suddenly remove this I4. If suppose I am removing this I4, what will happen? The current through each branch will change, voltage across each branch will change, and that will cause what? Transient. Because again the capacitor will take time to move from one voltage to what? Another voltage. It will take some time. So when we are removing some elements from the circuit, again it will create what? Transient. To give me the answer for one question, I am just giving you the one question, which type of questions they will ask. Okay, ready? Now, please give me the answer for this question. Transient are caused because. Why? This type of question in what GATE exam, MSQ, or what in engineering services exam, or ISRO exam, or BARC exam, and in number of competitive exams. Now, it is just like what MSQ. The transients are caused because. Why we are getting the transient in any circuit? The load is suddenly connected to or disconnected from the supply. Yes. Second point, this is the first point. Second point, of the sudden change in the applied voltage from one finite voltage to the other. Third point, because of the change in the stored energy in the inductor and the capacitor. Right? So these are the 3 points. Because of these 3 points, we are getting what? Transient. So Vignesh, Vicky, Startup, Ashok, very good afternoon, and Navneet. So this point is clear. Which type of questions they may ask? So we are going to revise complete concept of transient here. Okay, so please share the link of this session so that student will join. Right, because number of students are facing the problem on what? Transient. Analog completely depends upon the concept of RC circuit, resistor and capacitor circuit. Okay, and because of this we are getting the transient. First is correct. Second, of the sudden change in applied voltage, already I have given you the concept about the step signal, so second is also correct. Now third, of the change in the stored energy in the inductor and capacitor. Yes, what is the energy stored inside the capacitor? Half of CV square. That is normally represented by W. Half of CV square. What is the energy stored under steady state in inductor? Half of Li square. V is constant, I is constant. But when we are changing the components, right, what will happen? Or suddenly we are connecting or disconnecting the battery, then definitely there will be the change in energy across the inductor or what? Capacitor. Right? There will be the change. Okay? Because the voltage will change. If the voltage will change, energy across the capacitor will change. Current will change, and that's why the energy across the inductor will change. Capacitor stores its energy in electric field, and inductor stores its energy in what? Magnetic field. So that is the difference. So which answer is correct? All. First, second and third. That will become what? MSQ. Options A, options B, option C, option D, none of this. So A correct, B correct, C correct. A, B, C. Okay then. All are correct. This type of questions from the transient. We will solve number of questions like what? Switch is closed and what will be the value of I and so on. So my dear friends, now watch this diagram again. This is the transient. Transient response is the circuit's temporary response, and that will die out with the time. So when we are talking about the transient, always remember it is a temporary part. After some time the capacitor will charge and circuit will enter into what? Steady state. So when we are solving the question with circuit having what? Capacitor or inductor or capacitor inductor both, then the but sir, to occur the sudden change in the energy of an inductor, current through the inductor should change, which will not allow by the what about the point? Please watch this. Where is the sudden change written here? Please tell me. Surjit, watch this third point. Where is the sudden change is written here? In this case, load is suddenly connected. In this case, sudden change in the applied voltage is written. But in this case of the change in stored energy in the inductor and capacitor, where is the sudden change is written here? Is it clear point? No sudden change word is used in the third statement. Of the change in stored energy in the inductor and capacitor, yes, it will take time. Suppose if the energy across the capacitor will change from 10 milliwatt to 50 milliwatt, it will take time, yes, but that is the transient. Initially energy is 10 milliwatt, it will convert it into 50 milliwatt. From this point to this point it will take time, and this time is called what? Transient. And that is called what? Steady state. Under steady state, what will be the energy across the capacitor? 50 milliwatt. That is the reason. Okay. भाई बुला लो अपने सभी फ्रेंड्स को एक बार. कंपटीशन बढ़ने से नहीं, कंपटीशन नहीं बढ़ेगा, क्योंकि बहुत सारे नंबर ऑफ स्टूडेंट्स ने डिमांड की थी कि सर आई एम गेटिंग द प्रॉब्लम इन व्हाट फर्स्ट ऑर्डर आरसी सर्किट, एंड दैट्स व्हाई विद इन 2 hours or 3 hours आई एम गोइंग टू कवर ईच एंड एवरी एस्पेक्ट ऑफ व्हाट first order RC circuit, right? So please share the link of this session and ask them to join the session, and press the like button for your presence and simply subscribe our channel. Now that question is very, very important. We are going to discuss this type of conceptual question. So transient. Always remember, in particular circuit, always we have the two solutions. First is called transient, second is called steady state. Transient is the temporary part, steady state is the permanent part. Permanent part. When we are having the differential equation, try to understand, when we are having any differential equation, there are two types of differential equation. Everyone tell me, if this is the dy by dt plus ay is equal to 0. Tell me what is the order of this differential equation. Now the order of this differential equation is just what? 1. First order differential equation. If this is a first order differential equation and it is a homogeneous differential equation, for any homogeneous differential equation, the solution is what? There are two solutions from the mathematics. One is called complementary function and other one is called what? One is called complementary function and other one is called particular integral. Okay. So complementary function and particular integral. If you want to solve the y, you will get the two solutions. Complementary solution plus what? Particular integral. Now complementary solution is nothing but transient part. Complementary solution is nothing but transient part, and particular integral is what? Permanent part. But if it is a homogeneous differential equation, that solution will be 0. Only complementary function for homogeneous differential equation, right? Homogeneous. Second thing, if we are having the non-homogeneous differential equation, so we are having basically two types of circuit. So when we are getting this type of equation, any function here, this is called differential equation. And for this we have the two solutions. One is called complementary function and one is called particular integral. The particular integral means what? Steady state part, and this is called what? Transient part. Now, this is the first order differential equation. In RC circuit, we are having the two types of circuit. Everyone tell me, this is the first circuit. Only R and C are present, only passive elements are present. Second circuit, we are connecting a voltage source here. R and C. So normally we are getting these two type of circuit only. One is called source free RC circuit. This is a source free. There is no forcing function. No external independent sources are connected with this circuit. No forcing functions are present here. And that's why for this type of circuit, we are getting only first order differential equation. Second, it is a homogeneous differential equation. So tell me, what will be the solution for the first circuit, everyone? Only transient part or transient plus steady state part? Now here we are having one forcing function. This is called forcing function. We are giving the external battery in the second circuit. When we are providing the battery in the second circuit, it may be DC signal or it may be what? Sinusoidal signal. It may be exponential, and when we are providing the forcing function, then what will happen? We are going to get the two solutions. One is called steady state, one is called transient. Suppose I want to calculate the voltage across the capacitor. So in this case, I am going to get transient plus steady state part. In this case, we are going to get only one solution, that is only transient part, because it is a source free circuit, right? I think these two concepts are clear, everyone. These two concepts are clear. Yes, AKG, your answer is correct, that second circuit is, for second circuit we are going to get non-homogeneous differential equation, right? Now non-homogeneous. Now try to understand. To solve this type of questions, we are having the different methods. For example, if I want to solve this question or that question, I can use what? Concept of differential equation. I can use the concept of differential equation. We are going to get the linear differential equation. We are going to get the linear differential equation because it is a linear circuit, right? Second, number of students are comfortable with the Laplace, yes or no? How many students are comfortable? Laplace transform, right? And third type is what? Directly we are going to use the formula. We are going to use the formula, but when we want to use this formula, we have to find the initial value, we have to find the final value, and we have to find the time constant of the circuit, right? The time constant of the circuit. So I am going to give you the idea how to use this formula effectively, and I will try to solve one or two questions on differential equation, and I will try to solve some questions on what? One or two questions on Laplace transform. But in competitive exams, to solve objective questions, or when we are applying the concept of RC circuit in analog, we have to use what? Direct formula. Direct formula. Okay, so चलिए देखते हैं क्या क्या है. So that is the concept here. This is the, I am going to teach you the source free RC circuit. RC circuit with the source, how to calculate the time constant, each and everything about this topic. Okay then, I think now you are ready. So that is about the steady state response. Always remember, steady state response is a permanent part. तो ये लिखा हुआ है steady state response is the circuit's permanent response by applying the external excitation. Steady state region where the signals are not time dependent. time rate of change of the signal is equal to 0 or periodic, that signal will be periodic. This response is also called as forced response. What is the name of the steady state response? Forced response. And transient response is called natural response, right? Natural and forced response. Steady state solution is the particular solution of the, is a solution due to the source. When we are applying the external source, there will be a particular integral that is called what? Steady state solution. So steady state solution or forced response or what particular integral, these are the name of this response. Now, what is the nature? First of all, we will try to solve some questions, but get this idea. This is a time scale. On x-axis, this is the time scale. Let this time is t equal to 0. Right? Exactly. This is the step signal. This is the step signal. Suddenly at t equal to 0, it will become 10. This is the 0 point. This is the 10 volt. So this is represented by Vi is equal to 10 ut. 10 for t less than t greater than 0 and 0 for t less than 0. And that is called what? Sudden change. So how we can define this signal? So when I am going to define this signal, exactly just before 0, this is called 0 negative. T0 negative. T0 negative, Vi is equal to 0 volt. And exactly at t equal to 0 positive, Vi is equal to 10 volt. This type of change is called sudden change or abrupt change. Now, at this point, watch, this point is t equal to 0. This diagram is very important. This is called T0 negative and this is called T0 positive. Just before switching, after switching, that is called t equal to infinite. Now, when I am talking about that, circuit is in this position for long time. For long time means it is coming from what? Minus infinite to 0. 0 negative. Let. For long time we are moving like this. If we are moving like this, so from minus infinite to 0 negative, circuit will get the sufficient time. And exactly at t equal to 0, there will be the change. So my dear students, tell me what is the 0 negative? At 0 negative, circuit is under steady state or initial state. So always remember, when I am talking about the t equal to 0 negative, means the similar position is coming from minus infinite up to what? 0 negative. Circuit will get sufficient time, and that's why at this point circuit will be in steady state. Steady state. Now, just I am changing the position of the switch. When I am changing the position of the switch from 0 negative to 0 positive, again the initial state will start. Initial state will start from 0 positive. So this point is called initial state. Now, with new situation, with new condition, because there is a change at this point, that's why this point is called initial condition or initial state. Again the circuit will get the sufficient time at t equal to infinite. Again it reaches to what? Steady state. Again it reaches to steady state, right? So always remember, when I am giving, there is a sudden change at t equal to 0 negative or exactly at t equal to 0, exactly before switching, circuit will be in steady state. Just after switching, circuit will be in initial state. And again when we are giving the infinite time, again circuit reaches to what? Steady state with new conditions. With new conditions. So normally we are saying that circuit, the switch is open and after long time we are closing the switch, or switch is closed, For long time, now we are opening the switch. Long time means what? It is coming from minus infinite towards 0 negative. And long time means simply circuit reached to what? Steady state. Time at which a switch start operating initially. Yes, AKG, we will get the idea with solving some questions. Now, what I want to say, I am going to teach you the DC transient. Under a DC transient, DC means we are giving the DC signal. We are providing the 10 volt battery or a constant current source. These are the DC signal. So for DC, always remember, under steady state, what is the impedance because of the capacitor? That is given by 1 by omega c. Omega is the frequency, that is given by 1 by 2 pi fc. So capacitor for DC, F is equal to 0, and that's why ZC is equal to infinite. Impedance is infinite for the capacitor for DC signal. Under steady state, capacitor always acts as open circuit for DC signal. Capacitor acts as open circuit for DC signal. Right, under steady state. And when we open circuit means, what is the current through the capacitor? 0. Effectively open circuit means the current will be 0 through the capacitor. Similarly, when we are talking about the inductor, ZL is given by omega L, and for DC, this omega is 0, that is 0. Inductor acts as short circuit for DC under steady state. When we are talking that inductor acts as short circuit, means it will allow the current, but what will be the voltage across the inductor? 0. Inductor will allow the current, but what is the voltage across the inductor? 0 under steady state. That's why we are saying that it will act as short circuit and it will allow the current. That is called I0. So that is the representation of the inductor under steady state. Always remember, this is the short circuit. Short circuit means what is the voltage? 0. And it acts as what? Current source of I0. Now, just after switching, inductor, current through the inductor will remain same. If you want to find the initial value of the current through the inductor, then you have to find what? IL0 negative. First of all, you have to find the IL0 negative under steady state condition. If you want to find the voltage across the capacitor, initial voltage across the capacitor, then first of all you have to find the voltage across the capacitor exactly at 0 negative. 0 negative. When we are going to find this value, circuit is under steady state. Remember that point. And once we have the idea about that, you can find this value. That is the method, how to find the initial voltage, how to find the final voltage. I think these two concepts are clear. Anyone, you can ask any doubt about this topic? Yes, please. Now we are going to solve some important numericals. I am going to give you some important concepts. Yes. So this is the case. This is the under steady state. What is the impedance because of the capacitor? Under steady state, what is the impedance because of the inductor? Right? Inductor does not allow sudden change of current. Capacitor does not allow sudden change of voltage. And what is the initial value? What is the final value? Okay then. Now, first important circuit is source free RC circuit. First of all, we will discuss the source free RC circuit. Always remember, when we want to find the complete response, for any circuit, there will be the two response, transient plus steady state. This is called complete response of the circuit. Transient is temporary part, steady state is the permanent part. Complementary function plus what? Particular integral. Now I am going to explain two important circuit, that is called source free RC circuit and RC circuit with source. Okay, start. Now this is the RC circuit without source. We are going to get this type of response. This type of response, that is called exponentially decreasing function. Exponentially decreasing function. Okay, what will be the equation? Why we are getting this type of curve, exponentially decreasing function, right? And what will be the current through the circuit? And what is the initial energy across the capacitor? And what will be the final energy across the capacitor? Source free RC circuit. Try to understand now. When I am talking about the source free RC circuit, means there is only resistor and capacitor. Number of cases we have to solve this type of questions. Like this is, there is no external battery. This is called source free RC circuit. In a particular numerical, they will give you the idea that the initial voltage across the capacitor, like this is the, it will be given in the question, initial voltage across the capacitor may be any value that is given by V0, or you can say like this is the 10 volt and so on. Once you have the initial value of the voltage across the capacitor, you can also find the initial energy across the capacitor. What will be the initial energy? Half of CV0 square. Value of the C, value of the V0 initial voltage square, and you will get the initial energy across the capacitor. Now, how to find the equation? There are 2 or 3 methods. I will use first method, that is, it is a simple RC circuit. It is a, we are going to get the first order differential equation. How? Right, watch this. If I am writing the equation, let there will be the current I. This is the voltage across the capacitor, VC. When I am writing the KVL, it will given IR plus VC is equal to 0. I into R plus VC is equal to what? 0. We have to find the VC. Always remember, when this is the current, this is the plus, this is the minus, the current through the capacitor is given by C dVc by dt. So replace this I by C dVc by dt plus Vc is equal to 0 divided by Rc. Everyone tell me, what about this equation? Homogeneous or non-homogeneous differential equation? Or first order or second order differential equation? You are going to get this differential equation. Very simple. Very simple method. You have to get the command over the maths also. How to find out if we are having the first order differential equation, then what will be the procedure to solve this question? So this is the first order differential equation. Homogeneous or non-homogeneous? Now, because there is no forcing function, homogeneous. This d by dt is represented by d. Some students are confused that d by dt is represented by d, and this is the plus 1 by Rc into what Vc is equal to 0. You will get the d is equal to minus 1 by Rc. That is the method how to solve. Once you will get the root, that is minus 1 by Rc, what is the general solution for first order differential equation? Always remember that Vct is given by k e raised to power dt. What is the value of the dt? Minus 1 by Rc. That is the first root. It will become k e raised to power minus t by Rc. Second, once you will get this solution, how to find the value of k? simply from the initial condition. Exactly at t equal to 0, what is the value of the VC0? That is V0, or you can say simply 10 volt. Put in this equation, this will become 10 is equal to k e raised to power 0 is what? 1. That is the value of k is equal to 10. What will be the solution? VCT is given by 10 e raised to power minus t by RC. 10 e raised to power minus t by RC. That will be the solution. That will be the solution of this question. So that is from the mathematics. This is called complementary function. This is called the complementary function. That is the first order homogeneous differential equation. But in a network, we are not using this formula. We are, everyone, this is clear. This is a source free RC circuit. What is the initial voltage will be given in the question. This is the half of CV square, that will be the energy. And that is the solution 10 e raised to power minus t by RC, where 10 is the initial voltage, e raised to power minus t by RC. Now, second point, if I am going to use the concept of network first order equation, then directly we can find, always use this equation. VCT is equal to V final minus V final minus V initial e raised to power minus t by tau. When I want to use this equation, you have to use some concept here. First, initial voltage. V0 is called initial voltage. It is given in the question. 10 volt. Final voltage, exactly at t equal to infinite, what will happen? Because there is no external source, no external active source is present in the circuit, then what about the capacitor? Capacitor will completely discharge through the R. When the capacitor completely discharge through the R, means what is the final voltage across the capacitor? 0. And what is the final energy across the capacitor? It will be 0. Because this capacitor will completely discharge through the R, right? Third, time constant of the circuit. When I want to calculate the time constant, this is a very simple circuit. Always remember, in any diagram, if you want to calculate the time constant, you have to find the RTH into C. So in this circuit, when I want to find the RTH, remove the C. This is very simple circuit. Otherwise, in any circuit, if you want to find the RTH, always remove this C and find the RTH across A and B. When I am finding the RTH across A and B, that is simple R. What will be the time constant? RC. Because this circuit is very simple. Otherwise, remove C, very simple concept, remove the C and find the Thevenin's resistance across AB. How many students are comfortable with the Thevenin's theorems and so on? If you are not comfortable with the theorems, then I am going to take very important sessions on theorems. I think that is from the 5th of May, right? Daily one class, right? 1 hour class, evening class, and you are going to get the command over complete theorems. And theorem, Thevenin's theorem, Norton's theorem, superposition theorem, maximum power transfer theorem, Telegans theorem, reciprocity theorem. Always there will be question from this topic. We will integrate the topic with what? Analog. We will integrate the topic with the analog, and we will solve some questions on Thevenin's and Norton's from analog also. So that will start. So if you want notification, then join my Telegram channel, that is Electronics by Sanjay Rathi, right? And I will upload the PDF. Today I will upload the PDF for this session on my Telegram channel, that is Electronics by Sanjay Rathi. So if you have the link, then simply post the link. Otherwise, Electronics by Sanjay Rathi, and subscribe our channel and complete one topic I will cover here, each and everything about all the theorems. Yes, that is Navneet, yes. And for some student it is important for revision, and some new students, that is I am going to take one complete topic with what each and every important thing, very small things, what are the concept and so on, how we are going to use this type of formula. So now try to understand. If that is the formula, always remember we have to find the final value, we have to find the initial value, we have to find the time constant, and then again what will be the equation? Now the equation will be, what is the final value? 0. What is the final value? 0. What is the initial value? V0. E raised to power minus t by, what is the time constant? RC. Solve this. You are going to get the V0 e raised to power minus t by RC. That is nothing but 10 volt e raised to power minus t by. That will be the answer, right? And my dear students, after some practice, you will give the direct answer. That will be the question. You are watching the simple initial value and you will directly write this answer. Sir, VCT, because it is a source free circuit, initial value e raised to power minus t by RC. That is the answer. Within 5 seconds. Within 5 seconds you will get the idea. That is after practice. After solving 5 to 10 questions, you will directly write this answer. V0 e raised to power minus t by RC. Now, so that is the first method, but no need to use this method. It is because it is very lengthy. Second method, or directly third method. Right. Now, once you will have VCT, if you have any doubt, then you can ask, or you can give the general answer also. V0, this is the initial value. From this formula, it is called exponentially decreasing function. Why? Exponentially decreasing function means when we are putting the t, and what will be the value of VCT? When I am putting the value of t is equal to 0, VCT means t equal to 0, put here, it will become V0. 10 volt. When I am putting the t equal to RC, that is called tau, time constant, then it will become V e raised to power minus 1. Always remember the value of e raised to power minus 1. That is 0.368. You can calculate this value. It will become 0.368 of V0. And when I am putting the value 10, it will become 3.68. 3.68 volt. When I am putting the V0 is equal to 10 volt. So that is the answer. When I am putting the 3 RC, it will become e raised to power minus 3. When I am putting the t is equal to 4 RC, it will become v raised to power minus 4. Right? And when I am putting the t is equal to what? Infinite, it will become e raised to power minus infinite. This is equal to 0.05 of V0. You can check, nearly equal to. It is equal to 0.02 of V0. And this is become 0. This is become 0. And that's why it is called what? Exponentially decreasing function. Exponentially decreasing function. New students, always remember, it is the 10 volt. Initially, that is called V0. Initial voltage is this, it is the 0. This is the time. On x-axis, it is the time. On y-axis, that is the voltage across the capacitor. Initial voltage. Now, exponentially decreasing function means like this. This is the exponentially decreasing function. Exactly at one time constant, that this is the one time constant. RC. It will reduce up to what? 0.368 of initial value, or normally in words we are using the 37% of the initial value, nearly 37% of the initial value. It will discharge up to 37% of the initial value. Okay, that is the initial value is V0. It will become 0.368 of V0 in one time constant. That is exponentially decreasing function. Or in 4 time constant, it will decrease up to what? 98, decrease by what? 98%, and only remaining portion is what? 0.02, means 2% of V0. And exactly at t equal to infinite, it will become 0. But my dear students, we can't wait up to infinite, practically not possible. And that's why we are simply go up to what? 4 time constant or 5 time constant. After 4 time constant, we are saying that transient is over and circuit reached to what? Steady state, or maximum up to 5 time constant. After 5 time constant, there was the transient, and after 5 time tau, transient will be over. Circuit enter into what? Steady state. Are you getting this point? Why we are giving the boundary? Because we can't wait up to what? Infinite. And that's why on the basis of what? 4 time constant, or on the basis of what? 5 time constant. In control, we are using the similar type of concept, that is called settling time. On the basis of what? 5% error. On the basis of what? 2% error. So this is called 5% error. This is called 3 time constant. On the basis of 2% error, that is called 4 time constant. That is called settling time in control. Here we are saying that just transient is over. Okay. That is about the source free RC circuit. Very, very simple diagram, and number of questions on this, and we are going to solve some questions. But up to this point, everything is clear, everyone? Yes, please tell me. This is a source free RC circuit, exponentially decreasing function. चलिए इस क्वेश्चन का आंसर बताइए, फिर सॉल्व करते हैं. Yes. Now I will give the idea about what? RC circuit with source also. What should be done to find the initial values of the circuit variables in a first order RC circuit excited by only initial conditions? Only initial condition. Excited means there is no external battery is applied here. No external battery. Only initial condition. Just like a previous question. Only the initial conditions. Then what is the representation? Just tell me. Now, what should be done to find the initial values of the circuit variables in a first order RC circuit excited by only the initial condition? Now, if this type of questions, to watch the previous question, like this is the circuit. This was the circuit. This is the VC is given. Everyone try to understand. Now, if I am giving the current, let this direction of the current is given. Okay, no problem. This direction of the current is given. Always remember, capacitor does not allow sudden change of voltage. What was the initial current is given? Initial voltage is given in the question. VC0 is given as 10 volt. Okay, no problem. Let this is the 1 ohm, 10 ohm. 10 ohm. Okay. Now, initially we have to replace the capacitor by using what? Voltage source. If you are seeing that capacitor by an open circuit, my dear, AKG, it is under steady state. What is asked here? Excited only in initial condition. What should be done to find the initial values of the circuit variables? Initial values of the circuit variable. So first of all, what are the variables? First, I is the variable, current, initial values. VR is the variable, voltage across the resistor, it is variable. VC is the variable, voltage across the capacitor is the variable. So these are the three variables. What are the initial values? So initially, this capacitor will be replaced by what? Voltage source. Simply replace it by what? Voltage source. And what was the initial voltage? 10 volt. Now tell me, if I am giving the current like this, what is the value of the current? Everyone give me the value of the current. That is given as 10 ohm. What will be the value of the current here? So I am giving the traditional, that is the conventional direction of the current. If I am giving the conventional direction of the current, always remember, through passive elements we are giving the current like this. This is the plus, this is the minus, this is the plus, this is the minus, that will be the I. But when I am going to calculate the current, always remember, it will become, write down the KVL, 10I, or I am giving you the general answer, Ri plus what? V0 is equal to 0. What is the I is equal to? Minus of V0 by R. Minus 10 by 10, that is the minus 1 ampere. Minus 1 ampere, not 1 ampere. You are giving the wrong answer, Niranjan and AKG. And that is the concept. That is the concept. Everyone, watch this question carefully. What I am given, what I have given the direction, that is the direction. According to this direction, this I is what? Negative. This I is negative minus 1 ampere. What is the meaning of the minus 1 ampere? Always remember, that is the concept here. When I am saying that, we have the concept that any element, whether it is a resistor, inductor, capacitor or voltage source, anything, if this is the direction of the current and that is the polarity of the voltage, tell me, this will consume the power or deliver the power? This particular device will absorb the power, right? If suppose that is the element, if this is the direction of current, when it enter through the minus, leave the plus, it will deliver the power. This is called sign convention. That is called what? Sign convention. So it will absorb, it will deliver, right? Deliver the power. Okay, that is the concept. Now in this circuit, when I am talking about the RC circuit, there is only one element, that is the C. It has the 10 volt. When I am calculating the current, I am getting the minus 1 ampere and I am giving the direction I like this. But when I am getting the value, this is the minus 1 ampere. So what is the actual direction of current is what? Opposite. Actual direction of the current is opposite. Actually, that is the 1 ampere current. Initial current, I am talking about the initial current. That will. Means, what about this capacitor? Actually, this capacitor, it is not absorbing the power, it is delivering the power. And that's why what will be the final energy across the capacitor? It will become 0. That capacitor will give energy to the resistor. The capacitor will give energy to the resistor, and that's why the capacitor will discharge, because current enter through the negative, leave the positive. It acts like a battery. The capacitor acts like a battery, right? This is clear. Energy source, it will give the energy to the resistor, and that's why final energy will become 0. Capacitor will completely discharge through the R. I think this concept is clear, everyone. So that is important one. Always remember what is the direction of the current is given, how to find the current. Initially, capacitor is replaced by a voltage circuit, voltage source, right? Okay. Yes, final voltage will become 0 because the capacitor will discharge through the resistor. It will give the current and final the energy. The initial condition, always it is replaced by what? Voltage source. Now I am going to explain what RC circuit with source, then we will solve number of questions. बने रहिए आप लोग. all the time energy at the infinite will be 0. Yes, Vignesh. In that circuit, capacitor will deliver the energy, resistor will dissipate the energy, everything will be over. At t equal to infinite, what will be the current in the circuit? 0. What will be the voltage across the capacitor? 0. What will be the voltage across the resistor? 0. Everything will be 0. Because that energy is dissipated into the atmosphere through the resistor. Now, when I am talking with the RC circuit with the source, means we are giving the source here. This is the R, this is the C. Exactly at t equal to 0, the switch will be closed. This is the 10 volt battery. Now, if we want to solve this diagram is again very important one. लेकिन भाई बच्चे कहाँ हैं आप? Please share the link of this session. Now, watch this diagram. If this is the voltage source is given 10 volt, exactly at t equal to 0, this is closed. Right. Exactly at t equal to 0, if the switch is closed. Always remember, there will be some initial voltage across the capacitor. If there is some initial voltage across the capacitor, what will be the initial voltage? It will be given in the question. This is the V0. It may be positive. For example, V0 is what? 2 volt. It may be 0. Or it may be what? Negative. Are you getting this point? And the polarity of the voltage is given like this. Polarity of the voltage is given like this. So it may be positive, it may be negative, or it may be 0. If the initial voltage across the capacitor is 0, for example, try to understand. If the initial voltage across the capacitor is 0, then it does not allow the sudden change of voltage. VC0 negative is equal to VC0 positive is equal to what? 0 volt. So if it is 0 volt, then the capacitor is represented by what? Short circuit. So initially we are saying that the capacitor will act as what? Short circuit. Capacitor will act as what? Short circuit. Because there is no voltage. When the switch is closed, this will act as what? Short circuit. So initially, capacitor act as short circuit. But always remember, what is the initial voltage? What is the initial voltage across the capacitor, everyone? 0. Then it will act as what? Short circuit. If once it will act as short circuit, you can calculate the initial current through the circuit, I0. That is nothing but 10 by R. 10 volt by R, or applied voltage divided by R. That is, I am giving you the general formula. Third thing, what will be the voltage across the resistor? The complete voltage will come across the resistor. Finished. What is the initial voltage across the resistor? Vs. That is nothing but I into R. I think this concept is clear, everyone. Here, number of students are saying that, sir, initially capacitor acts as short circuit. My dear, when the initial voltage across the capacitor is 0, yes, definitely it will act as short circuit. But if the initial voltage across the capacitor is not 0, then what will happen? Try to understand this diagram. If it is initially it is 2 volt, if it is initially 2 volt, then the capacitor is converted by a battery of 2 volt. This is nothing but initial voltage across the capacitor. Or this diagram is exactly valid for t equal to 0 plus. Are you getting this point? Already we have solved one question. So initially the capacitor acts as a battery or a voltage source. That's why. Once the capacitor is converted, you can find the initial current. Now tell me what will be the initial current. Not this statement is wrong. Initially it acts as short circuit. No. Initially it acts as a battery of V volt or V0 volt. What will be the initial current? Vs minus V naught initial voltage upon what R? Vs minus V naught upon R, right? And what will be the current across the resistor initially? I into R. Yes. Now, some students, right now, everyone tell me what will be the final voltage. Always remember, this is the diagram for t equal to 0 plus. This is the diagram for t equal to 0 plus. Exactly at t equal to infinite, always remember, for DC transient, the capacitor will act as what? Open circuit. Capacitor will act as open circuit. So exactly at t equal to infinite, make the capacitor open circuit, because we are giving the DC transient, DC voltage here. Simply you have to make the DC. For DC, this will act as what? Open circuit. Means final current through the capacitor is 0. Everyone, what is the drop across the R? 0, because the current is 0. The complete voltage will come across the capacitor and it will become 10 volt. That is called what? Final voltage. It forced, that 10 volt forced the capacitor to charge up to what? 10 volt. Are you getting this point? So my dear students, if the initial voltage is 0 volt, again it will charge up to what? 10 volt. If the initial voltage is 2 volt, again it will charge up to what? 10 volt. Or if the initial voltage is minus 2 volt, again it will charge up to what? 10 volt. So in all the cases, what will be the final value? In all the cases, the initial value will remain same, but the final the initial value is different, 2, 0, minus 2. But what about the final value? It will remain 10, it will remain 10, it will remain 10. 10, 10, 10. Okay? Because that forcing function 10 volt will force the capacitor to charge up to what? 10 volt. It doesn't matter what is the initial value. Right? Are you ready to solve some questions or some diagrams? Yes. So that is the, if once you have the initial value, once you have the final value, once you have the time constant, directly you can write the equation here. Always remember, you can write VCT, V final minus V initial e raised to power minus t by tau. This is a general equation, my dear student. This is a general equation. We are using this equation to find the voltage across the capacitor. We are using this equation to find voltage across the resistor, and also we can use the equation to find the current through the circuit also. For first order circuit, this is the very, very important equation. Now, for the given circuit, yes, AKG, I am giving you the concept about what? DC transient. And that's why for DC, under steady state, the voltage will be what? Two things. DC means what? Constant. Or if suppose we are asking about the periodic signal, like what? Sinusoidal signal, that it will be sinusoidal under steady state. Yes, that is clear. In this session, I am simply explaining the DC transient. DC. It may be zero, source free response. If I am connecting any source, that is the DC source, constant source. That's why we are getting the final value constant. Now, VCT. What is the, always remember, I am giving you one important table here, and now I am going to use this equation also. This is the t equal to 0, this is the t equal to infinite, this is called steady state value, final value. Tell me, what is the voltage across the capacitor in the given circuit? This is, I am giving you the 10 volt, exactly t equal to 0, the switch will be closed. And the initial voltage across the capacitor is like V naught, it may be 2 volt, or 0 volt or minus 2 volt. This is the direction of the current I. This is the voltage across the resistor VR. Exactly at t equal to 0, the switch is closed. What is the initial voltage across the capacitor? V0. It may be 10 volt, it may be 2 volt, 0 volt, minus 2 volt. Final value is fixed, that is the Vs. What is the initial current through the circuit? Always remember, Vs minus V0 by R. Vs minus initial voltage across the capacitor V0 divided by R. It may be 0, it may be 2 volt, it may be minus 2 volt. But final value, final current is always 0. Because in this circuit, finally the capacitor will act as what? Open circuit. Now, what is the initial voltage across the resistor? Initial voltage across the resistor is nothing but Vs minus V0, that is IR. Vs minus V0. If initial voltage across the capacitor is 0, the complete voltage across the R, 10 volt. If this is 2 volt, 10 minus 2, 8 volt. If this is minus 2 volt, what will be the voltage across the resistor? 12 volt. Initial voltage will become 10 minus of minus 2, that is become 12 volt. What will be the final voltage across the resistor? IR, 0. What is the time constant of the circuit? RC. Once you have the time constant, my dear students, we can find anything. What is the voltage across the capacitor? Final value 10 volt. Right? I am giving you the general answer. Vs minus, what is the final value? Vs. What is the initial value? V0 e raised to power minus t by RC. Easy. Put the value of Vs and V0, you will get the voltage across the capacitor. If you want to find the voltage across the resistor, what is the final value? 0. What is the final value? 0. What is the initial value? Vs minus V0. Remember that. Initial value is nothing but Vs minus V0. E raised to power minus t by RC. Now, when I am solving this, general answer Vs minus V0 e raised to power minus t by RC. That is answer. If the V0 is 0, then it will become Vs e raised to power minus t by RC. I am giving you the general answer. What is the current? What is the initial final value? 0. What is the final value? 0. What is the initial value? Vs minus V0 divided by R. E raised to power minus t by RC. This is cancelled out and it will become Vs minus V0 upon R e raised to power minus t by RC. T by RC. Yes, I will write on the second page. That is the current through the inductor, current through the capacitor. Always remember, this is the initial value e raised to power minus t by RC. So we can find, no, why 2? Why you are writing the 2, my dear? AKG, it is not 2. It is not 2. What is the initial voltage across the resistor? 8 volt. It depends upon the value of the V0. So always remember, I am going to give you the idea how to find the voltage across the capacitor. This is the formula. Final voltage minus final minus initial voltage e raised to power minus t by RC. That is the 0 Vs minus V0 e raised to power minus t by RC. That is the 0 Vs minus V0 e raised to power. So finally the I will become, this is the formula. Finish then. Okay. That will be the case in any type of questions. So ऐसे ही we are writing some questions in GATE exam. Suppose the initial voltage is, right, for this circuit. Everyone give me the answer. I want to ask some answer. This is the 20 volt battery. This is the R. This is the C. and the voltage across the capacitor, initial voltage across the capacitor is 10 volt. Then for VR, which answer is correct? Voltage across the resistor, which answer is correct? For VR, which answer is correct? This is the time. This is the VR. VR, this is the VR. This is the VR. Tell me, out of this, which answer is correct? Yes, please. AKG. Right? Now, always remember, what is the initial voltage across the capacitor you have to find. What is the initial voltage across the capacitor? This is the 20, that is the 10. 20 minus 10, that is what? 10 volt. Now, again the capacitor will further charge. When the capacitor will further charge, what will be the voltage across the resistor? It will decrease from the 10 volt up to what? 0 volt. That is the from 10 volt to 0 volt finally. So answer B is the correct one. Now, in the same question, if I want to ask which is the correct answer for voltage across the capacitor, everyone, which is the voltage across the capacitor, on the same diagram, if I want to ask what is the correct answer for the voltage across the capacitor, which is the correct one? I'm talking about the VC. No problem, that same diagram. Now the VC, A, B, C, D, which answer is correct for the voltage across the capacitor? Initial voltage across the capacitor is 10 volt. Now Niranjan, you are giving the answer D. It will start from the 0. But my dear, what is the initial voltage across the capacitor? Already it is 10 volt. If it is, yes, now it is correct. If it is 10 volt, then it will start charging from 10 volt and it will finally reach up to what? 20 volt. And that's why this answer is correct. This answer is correct. Tell me, it will cross the 0 line. Everyone, tell me, it will cross the 0 line. No, it is not going to cross the 0 line because 0 line is here. And that is, it is from 10 to 20 volt. It will never cross the 0 line. Right? But if the initial voltage is minus 10 volt, if the initial voltage is minus 10 volt, then what will happen? Minus 10 volt. Now watch. If the initial voltage is minus 10 volt, then this line is here. It will start from minus 10 volt and it will charge up to what? 20 volt. That will be the voltage across the capacitor. Initially it will start from the 10 volt and that is the charge up to what? 20 volt. Yes, in that case it will cross the zero line, right? It will cross the zero line from minus 10 to what? 20. Now what is the initial voltage across the resistor? The initial voltage across the resistor 20 minus of minus 10, 30 volt, and then it will switch from 30 volt to what? 0 volt. This is nothing but voltage across the resistor. 30 volt to what? 0 volt. volt to 0 volt. I think this concept is clear, everyone. So this is the voltage across the capacitor and that is the voltage across what? Resistor. And finally what will be the current? 0. Under steady state the capacitor will act as open circuit and the current will be 0. So this type of questions in GATE exam, this type of question in engineering services exams, and this is about the RC circuit. Now we are ready to solve some questions. Do you want to solve some numericals? Yes or no? Yes, this is about the RC circuit, right? This is about the RC circuit, first order RC circuit, source free RC circuit, and what? RC circuit with the source. And always remember, you have to use this formula according to which you are getting the answer. If the initial voltage is negative, definitely it is going to cross what? 0 line. If the initial voltage is not negative, it will never cross the 0 line. Never cross the 0 line. Okay. Sir, VR is exponentially decreasing and VC is exponentially increasing. Yes, we can say. VC is the exponentially increasing function and VR, voltage across the resistor, is exponentially decreasing function. AKG and everyone, tell me why we are getting the exponential equation in every case. Why we are getting the exponential equation? Why there is an exponential charging? Why there is an exponential decreasing of the voltage across the resistor? Why? What is the reason? Reason behind this is what? Current. Current is exponential function. How? Simply, if I want to calculate the current, what is the equation for the current? I final minus I final minus I initial e raised to power minus t by tau. If try to understand, in this circuit, if the initial voltage, this is the final voltage, like this is the 20 volt, this is the R, that is the C, and let this is the 30 ohm. The initial voltage across the capacitor is minus 10 volt. Tell me, what is the initial current? 20 minus of minus 10 volt upon what? 30 ohm. That is 1 ampere is the initial current. And what will be the final current? 0. Time constant is RC. It will become 1 e raised to power minus t by RC. What about the current? Current is the exponential function. Once the current is the exponential function, it is exponentially decreasing function. Everything will be exponential. Everything will be exponential. Watch this. This is exponentially decreasing function I. Okay. What will be the VR? VR is nothing but IR. It will become e raised to power minus t by RC into R, because it is 1 ampere into e raised to power minus t by RC. This is the exponentially decreasing function, 1 e raised to power minus t by RC. What will be the voltage across the capacitor? Always remember, voltage across the capacitor is given by Q by C. Q by C. What is the Q? Integral of I. I dt. When I am integrating, what is the integration of the exponential function? What will be the integration of exponential function, everyone? Exponential. So I am getting the point that this is the exponential function. If I am going to integrate it, it will become e raised to power minus t by rc into what? Rc. I think that is the formula, yes or no? Yes. It is the 1 by c, yes. Now, if I am integrating this formula, right, what I am going to get the idea? Exponential function. What will be the limit? That is the formula. Integration. Put the limit and you will get the exponential equation. So that is the problem. Everything is exponential because current is exponential. If you want the linear charging of the capacitor, always remember one thing. Current should be constant. Current should be constant. If we want the linear charging of the capacitor, that will be the question, linear charging of the capacitor. So some student will ask, some student will give the answer, sir, current should be linear. No, if we are going to give the current linear, let this is the linear. What is the meaning of the linear? It is a function of the time, 5t. That is the linear. This is linear means what? It is a ramp function. 5t, yes. 5 is the slope of this line. But when I am integrating it, when I am integrating to get the voltage across the capacitor, 1 by c integral of I dt, 1 by c integral of 5t dt, and it will become 5t square by 2c. Tell me, is it a linear? No, it is a parabolic function. It is not linear. If you want the linear charging, current should be constant. That will be the objective question. Current should be constant. When I am giving the constant current, 1 by c integral of I dt, so what will become? I by c into t. That is a linear charging of the capacitor. Everyone, this concept is clear. This is a new concept in a RC circuit. Why we are getting the exponential charging? Because the current is exponential. Current is an exponential function, and that's why charging of the capacitor is exponential, voltage across the resistor is exponential, everything is exponential, right? When we are providing the constant current through the capacitor will charge linearly, and that is the concept used in what? Analog, because we are using this concept to generate what? Triangular wave, because we want there should be the linear charging of the capacitor. There should be the linear charging of the capacitor, and that's why we are getting the triangular wave like this. Okay, like this, triangular wave. What is the triangular wave? Charging, discharging. That is linear charging and linear discharging of the capacitor. No, in RC circuit we are not going to get that constant current. AKG, yes. In simple RC circuit we are not going to get the constant current. But in analog we are providing the we are connecting the operational amplifier, or we are connecting the current mirror circuit to provide the constant current through the capacitor. Okay. If simple in RC circuit, the nature of the current will be always exponential. Always exponential. Right? This topic is clear to you, everyone? Yes, you can say approximately, you can say. Approximately you can say. Always remember one thing. E raised to power minus x. What is the e raised to power minus x? 1 minus x plus x square by factorial 2 minus x cube by factorial 3 and so on. Yes or no? That is the series. But if this x is very, very small, then what will happen? X is very, very less than 1. Then I can say e raised to power minus x is nearly equal to what? 1 minus x. And that is converted into what? Linear. Exponential is converted into what? Linear. Now, if that will be the case, for example, I am writing I is the function of 1 ampere. I am getting the initial current e raised to power minus t by RC. If this RC is very high, very, very high, then what will happen? This x will become very small, and then this equation is it will become linear equation. Are you getting my point, everyone? What is the one method to make the linear? Time constant should be high. Time constant should be high. Then we can assume that it is a linear. Actually, it is not linear, but we are assuming from the mathematics. I think this concept is clear to you. This is approximate formula. Approximate formula. But if you want actual linearity, then always remember there should be the constant current through the capacitor. Constant current through the capacitor. Okay, I think up to this point everything is fine now. Now, last answer, please give me. Capacitor does not allow sudden change of voltage. Yes, okay. But is there any chance to provide the sudden change? Is there any chance? And why it is not providing the sudden change of the voltage? Last concept, and then we will solve numericals. Last concept. We are saying that capacitor does not allow sudden change of voltage. Okay. So if it does not allow sudden change of voltage, then why does not allow sudden change of current? Because for example, what is the voltage across the capacitor? Charge upon capacitance, Q by C. And what is the Q? Integral of IT, IDT. Integral of I dt. If we are giving the finite current, for example, try to understand this concept. If I want to charge the inductor by 10 coulomb, for example, I want to charge the capacitor. I want to charge the capacitor by 10 coulomb. Everyone give me the time. If suppose I am providing the 1 ampere current, how much time is required? Everyone. I want to 10 coulomb. Always remember this current charge is what? IT. If I am giving the I, so what will be the time required? Tell me. If I am giving the 1 ampere, then 10 seconds is required. 10 seconds is required to charge the capacitor by 10 coulomb, right? Second, if I am giving the 10 ampere current, then how much second is required? Only 1 second is required, right? If suppose I am giving the 100 ampere current, it will require 0.1 second. 1000 ampere, it will require 0.01 second, and so on. When I am increasing the current, what about the time will decrease? If suppose I am providing the infinite current, then how much time is required, everyone? Suppose I am giving the infinite current, then what will be the time required? If the current is infinite, practically not possible, but I am just saying that infinite current, then the time required will be 0. And in that case, capacitor will suddenly charge, and capacitor will allow the sudden change of what? Voltage. When we are providing the infinite current means what? Impulsive current. Infinite current is nothing but impulsive current. So when the current is impulsive in nature, impulse function, then it will allow sudden change of voltage. Always remember that. When I am integrating any impulse function from 0 negative to 0 positive, it will be 1. This is the delta is equal. It will give the infinite, this is the integration of the impulsive function in zero interval will give you the finite value. So always remember one thing, if the current is impulsive in nature, it will give the finite charge. This will be the finite if it is infinite or impulsive, and because of this finite charge, capacitor will suddenly allow the sudden change of voltage. I think this concept is also clear. That is the last concept about the RC circuit, when it will allow the sudden change. देख रहे हो, for your watch your battery of your mobile, initially 10 hours to charge the mobile. Initially 24 hours or more than 24 hours is required to charge the battery. Now 12 hours, then 5 hours. Now these days we can charge our battery within 15 minutes. Yes or no? Yes or no? Yes, it is possible to charge our mobile within what? 15 minutes. 15 minutes. Now after some times it will become 10 minutes, then 5 minutes, then what? 2 minutes, 1 minute, then what? 1 second, and then what? Suddenly it will charge. So that is, we are reducing the charging time of the battery, and that is the major problem with what? Electrical vehicles. It will take time to charge the battery of what? Electrical vehicles. We are now trying to design the circuit so that we will be able to charge the battery suddenly. Yes or no? That is the case. 30 watt fast charging charger. Yes, that is the case, because it will provide the large current. Okay then. So I think this is the concept. Now try to solve some questions. Very easy questions. Please first of all give me the answer for this question. Fast, 10 minutes, 10 to 20 minutes, try to give me the answer, and please ask them to students to join the session. Okay. In the circuit shown below, the switch S is closed at t equal to 0. So how many students are new here? ये AKG, yes, we are saying that big battery takes long time, but again we will increase, if we are increasing the amount of the current, again it will take somewhat small time, right? For example, if you want to prepare the bank PO, yes or no AKG, we can relate with that. If suppose I want to prepare what? Bank PO, it will require what? 3 months study work, more than sufficient 3 months. If I want to clear what? Normal AE JE exam, state level exam, it will require 6 months. If I want to clear the national level exams like what? GATE exam, it will take around minimum 10 to 12 months. Yes or no? If I want the single digit rank, the what? Huge syllabus, it will take more time. If suppose I want to clear what? Engineering services or civil services exam, again it will take what? 1.5 years or 2 years, right? But suppose we have only 6 months for GATE exam. Is it possible? Yes. Suppose we are having only 3 months for GATE exam. Is it possible? Yes. You have to increase your effort. Initially we are giving the 5 hours. Now we have to give what? 10 hours. After, if suppose we want to clear the GATE exam within 3 months, you have to give what? 15 hours. 15 hours study, and you will clear the GATE within 3 months. Yes, it is possible. Effort. You have to increase the effort then. Simple. In this case, we have to increase what? The value of the current. It will take less time. That is the value. Now tell me, in the circuit shown below, the switch S is closed at t equal to 0. The magnitude of the steady state voltage in a volt across the 6 ohm resistor. This is the 6 ohm resistor. 3 ohm, 10, 2, 10 volt battery. This is the capacitor is connected here. This is the DC battery. This is a DC battery. Yes. Tell me what will be the answer. So in this question, if it is asked about the steady state, remember that under steady state, capacitor act as what? Open circuit, because this is a DC. It is a DC source. Capacitor act as open circuit, then the complete branch will act as open circuit. And then 6 and 3 are in parallel. Always remember 6 parallel with 3. 6 into 3 upon 6 plus 3, 2. So it is a battery. This branch will act as open circuit. Remove that branch. These are the two resistors connected in parallel. You have to calculate the voltage across what 6 ohm battery. This is nothing but voltage across the 6 ohm and 3 ohm both. V 2 ohm. This is 10 volt. Now what is the parallel combination? 2 voltage division rule. According to voltage division rule, what is the voltage across the 6 ohm battery? 2 divided by 2 plus 2 into 10. 5 volt. Simply half divided. That answer, why you are giving the minus, Vignesh? Minus 4.54 volt. Why? What is the parallel combination of this 6 and 3? Everyone tell me. What is the final voltage? 6 and 3. Parallel combination is 2. And this is the 2. So that capacitor will act as open circuit. Remove this branch there because there will be the no drop. Now these are connected in parallel. That is, now these two are connected in what? Series. According to voltage divide rule, what is the voltage across this combination? 5 here, 5 volt here. Right. The magnitude, it is asked what magnitude. I think that is clear. AKG, you are giving, okay, now 5. Everyone, that is clear. Give me the comments in the comments box. And I will give you some assignments to write the answer in comments box. And I will take the screenshot of that, and in next class, in next coming classes, I will mention your name, that Vignesh or Navneet or AKG or any other students given the correct answer for this particular question. Okay, so write your answer in comments box. I will give you some assignments also. This is the 5 volt. I think this is clear to you. Now, in the circuit shown, VC is 0 volt at t equal to 0 second. Dekho, if the initial voltage across the capacitor is 0, we can say that initially the capacitor will act as what? Short circuit. For t greater than 0, the capacitor current where t is in the second is given by. T is in the second is given by. So what is the initial current through the capacitor? What will be the final current through the capacitor? And what is the time constant of the circuit? That will be the concept. Yes sir, can we solve before switching? Before switching, in this diagram, 1 minute, tell me, if I want to solve the before switching, tell me, 1 minute. In this question, before switching, what is the voltage across the capacitor? Is it given? Is it given? What is the initial voltage across the capacitor? No. If you want the answer before switching, then you have to get the idea what is the voltage across the capacitor, because before switching that battery is not connected to the circuit, and that's why the diagram is like this. Everyone, Vignesh Vicky is asking that before switching what will be the answer here? Do you have any idea what is the voltage across this capacitor? No. If we have no idea about the voltage across the capacitor, remove this. This branch is removed because it is a floating resistor and 10 volt is removed. If the initial voltage across the capacitor is known, then you can find. That is, again you have to apply the voltage division rule. This is the 2 ohm resistor. That is the magnitude. That will be the magnitude. If you are assuming that 0 volt means it will become 0. If we are assuming that the voltage across the capacitor is 0, then 1 minute. That is I am talking about the steady state voltage, not the initial voltage. Okay. Okay, now please give me the answer for this question. Everyone. In the circuit shown VC 0 volts at t equal to 0 second, for t greater than 0, the capacitor current where it is in the second. Always remember, initially the capacitor will act as short circuit. Initially the capacitor will act as what? Short circuit, because there is no voltage. When this capacitor will act as short circuit, this will short circuit the 20 kilo ohm resistor also. 10 volt. Watch this. What is the initial current through the capacitor? IC. IC 0 positive is given by 10 minus 0. It is the 0 volt. What is the current through the 20 kilo ohm? 0. So 10 minus 0 by 20. This current I will pass through the IC. 10 by 20, that is nothing but 0.5 milliampere. Current will be in milliampere because resistance in kilo ohm. That is the 0.5 milliampere will be the current. Now, under steady state, what will be the current? This is the diagram exactly at t equal to 0 plus, because initial voltage across the capacitor is 0. Under steady state, this capacitor will act as open circuit. That's why, what will be the current? 0. This is the exactly at t equal to 0 plus. This is the 20 kilo ohm, this is the 20 kilo ohm, this is the 10 volt. What will be the voltage across the capacitor under steady state? Is given by 5 volt. This is the voltage division rule. 5 volt. Now, what will be the time constant of the circuit? Always remember, in this case, if you want to find the time constant, remove the C, find the RTH of this circuit. To find the RTH, this 10 volt battery will act as short circuit. Time constant, this 10 volt battery will act as short circuit. Remove the capacitor across A and B. This 20 kilo ohm, this is the 20 kilo ohm, this is the A, this is the B. What is the RTH? RTH is nothing, 20 parallel with the 20, that is the 10 kilo ohm. Once you will get the RTH, what will be the IC? What will be the time constant? RTH into C. Value of the C is 4 microfarad, 10 kilo ohm. 10 into 10 raised to power 3. 4 microfarad, 10 raised to power minus 6. This is the 10 to the power 4. It will become 0.04. 0.04 second. 0.04 second. Now you have the initial value, you have the final value. Simply use the formula. What is the formula? Final value minus initial value e raised to power minus t by tau. Final value 0, What is the initial value? 0.5 milliampere. It is in milliampere, e raised to power minus t by 0.04. 0.04. Now it will become 0.5 e raised to power. This is the 100 by 4, that is the 25t. Very, very simple question. Yes, AKG, your answer A is the correct one. How many students are comfortable with this type of questions? That is the A answer. Okay, then next one. Next, in the circuit given below, the switch has been in a position 1 for a long time, for quite a long time. Again, this is the switch. It is at position 1 for a long time. Exactly at t equal to 0, it will move from switch 1 to 2. At this position, what is the time constant? Now, why I am choosing this question? Always remember, we are calculating the time constant for t greater than 0. So exactly at t equal to 0, the switch is closed, switch is moved from position 1 to 2. Now, if I want to calculate the time constant, so what is the new position? This is the new position. So always remember, you have to calculate the time constant for this portion only. This is connected here, 1 microfarad. This is 100 kilo ohm, and that is 100 volt. Simple. First of all, calculate the time constant of this circuit. This is the position number 2. 100 into 10 raised to power 3 into 10 raised to power minus 6, 10 raised to power minus 1 second means what? 0.1 second. That will be the time constant of the circuit. Always, new students, always remember, if you want to calculate the time constant, always calculate the time constant for this portion and remove this portion. Everyone, tell me, what is the initial voltage across the capacitor and what is the final voltage across the capacitor? So final voltage, that is the diagram. This is valid for t greater than or equal to 0. And that's why the final voltage, finally this capacitor will act as open circuit. The final voltage is 100 volt. Now, what is the initial voltage across the capacitor? When I want to calculate the initial voltage, means you have to calculate what? T0 negative. Exactly at T0 negative, what is the voltage across the capacitor? Right? What is the voltage across? No need to find the RTH. Why you are going to find the RTH? Simple direct circuit. That is because that switch is initially connected here. Now this is connected here. No need to calculate AKG. Right. Now, if you want to find the initial voltage, what is the initial voltage? Everyone give me the answer in comments box. This 50 volt is battery is connected here, 10 ohm is here connected here, 100 ohm is connected here. What is the initial voltage across the capacitor? If you want to calculate the initial voltage, always remember, you have to draw the diagram for T0 negative. And at T0 negative, this switch is connected at position 1. This is the capacitor. This is the 100 ohm resistor. $50 battery, 100 ohm resistor. Now Navneet, voltage across this capacitor will act as open circuit at t equal to infinite, at t equal to 0 negative, because at this point circuit will be in steady state. So what is the initial voltage across the capacitor? Vc0 negative is equal to Vc0 positive. Now, according to voltage divide rule, remember that 10 divided by 10 plus 100. No, because there will be the current, my dear. there will be the current in this loop. Everyone, are you getting this point? There will be the current, no doubt. Current through the capacitor will be 0, but there will be the current, and according to which we have to apply the voltage division rule. Second thing, watch the polarity. Polarity is what? Negative. AKG, watch the polarity is negative. Second thing, my dear, always read the question carefully. This is not 100 ohm. This is the 100 ohm and that is the this is the 100 ohm and that is the 10 ohm. Watch the question carefully. Why you are giving the 25 volt? That is the wrong answer. Right? This is the minus 50 volt. Because the polarity is reverse. Watch this polarity. And what is the VC now? I am talking about this VC. This VC is negative. Minus 500 divided by 110. Minus 50 by 11. Vignesh, again you are giving the minus 25. My dear, यहाँ पे 10 ohm है, 100 ohm. This is not at 100 and 100 or 10 or 10. This type of mistake in exam hall, please try to avoid this type of mistake. These are called silly mistakes. Okay. Minus 50 by 11. Once you will get the initial voltage, they will ask another type of question, let option A, which is the correct one. What is the final voltage? Final voltage is the 100 volt. This type of answer you are going to get, that will right. Now, which answer is correct, everyone? Which answer is correct? A, B, C, D. A, B, C, D. Which answer is correct for this question? So, if you have the final value 100 volt, if you have the initial value, then final value, initial value, exponentially increasing function. What is the time constant? Already we have the time constant, that is the time constant 0.1 second. So from this we are getting the answer. Always remember that is the initial value, final value is the 100 volt. That is wrong. If you are making the silly mistake, that will be your answer wrong. That is wrong. You have to check the polarity. Then answer B is the correct one. Now, once you will get the equation, they will ask exactly at what time, try to understand, exactly at what time it will cross the zero line. Exactly at what time it will cross the zero line. Now, once you are going to get the equation, VC is equal to what? V final 100 volt. V final 100 volt, V initial 50 by 11. V initial is what? Minus 50 by 11. E raised to power minus T by RC. What is the RC? 0.1 second. Because in this question the time constant is 0.1 second. Right? Then if I want at what time it will cross the 0 line, so let at t equal to t1 Vc is equal to 0. Put here 0, it will become 100 minus, ये हो गया minus minus plus 1150. I am correct? Please check my calculation. This will become 1100 plus 50, 1150 by 11 e raised to power minus 10t1. 10t1 because exactly at t1. From this here it will become 100, then 10t1 it will become 1150 divided by 11 divided by 100, and now you are going to get 10t1 is equal to log of 1150 divided by 1100, and that is what is the t1 is equal to 1 by 10 log of natural log, and you will get the answer. Is it clear now how to find, how to solve the question, everyone? So that is, first of all you have to find the equation. Once we are getting the equations, then we can apply formula final minus initial e raised to power minus t by tau. Once you will get the equation, what is asked in the question, exactly at what time it will cross the 0. You put the value 0 here, put the t1 here, solve this question, find the log. Always remember that suppose we are making the silly mistakes, and if we are going to get the negative value, that will be wrong. Always time will be what? Positive. Time will be positive. If we are going to get the negative answer, means there is some silly mistakes or some conceptual mistakes. Always remember, check this. The time should be positive, right? Or in this way we can solve this type of questions. So hope so this question is clear. Now time for assignment. That is the first question, everyone. Assignment number 1, give your answer in comments box. This is the 20 volt battery. This is the 10 kilo ohm resistor. Exactly at t equal to 0 the switch is closed. 20 microfarad capacitor and 100 kilo ohm resistor. That is the question. Read the question carefully. What is the initial voltage and what will be the finally steady state voltage and the time constant of the circuit. Very simple question. First one. Then that is the diagram. You can take a screenshot of this. I will upload the PDF on my Telegram channel, that is Electronics by Sanjay Rathi. And now I am going to start taking one session on what theorems, how many students are interested and what you want actually. Please give your comments in comments box, so that I will try to cover those type of questions in my session on theorems. If you have any questions, then again you can post those questions in my Telegram channel, so that I will cover those questions in my session. Okay, that is the case. Now this is the another question, assignment number 2, right? Take the screenshot. Now try to solve this type of questions. Give the answer in comments box. This is very important one. Assignment number 3. 4 mega ohm resistor, exactly t equal to 0 switch is closed. 0.5 microfarad capacitor, 0.5 microfarad capacitor. This is called VC1, that is called VC2. Then which answer is correct? Okay, so these are the assignments. Now try to solve this question and give me the answer in comments box. Okay then. Thank you for attending the session. Already we have solved number of questions. I have given you the concept. Try to solve the questions. You are on BYJU'S Exam Prep. Always remember, transient, or especially what first order RC circuit, source free RC circuit and RC circuit with the source. This is very important topic, right? Get the command over this topic, try to solve the assignments and give me the answer on comments box. And for PDF, join my Telegram channel. Like the session, share the link of this session and subscribe our channel. Thank you for attending the session. Thank you and good day. Thank you.